Hi there, welcome to the practice questions on being able to find the nth term of a quadratic and a cubic sequence. What I'd like you to do, first of all, is to pause the video and have a go at these three questions for yourself, work out the nth term for them, and then when you're happy with your answers, then restart the video and I will go through the model answers with you. So if you pause the video now, have a go at question 1, 2 and 3, working out the nth term of these sequences. Hi, welcome back. Let's now go through these model answers for these three questions. Now I'm going to work out the nth term for these three sequences. Starting then with question 1. What I'd like to do first of all is start and work out what the difference is between the terms. So first of all, if I have a look between the terms and do this on the question, we can see that we've got a difference here of 4 and then 8 and then 12 and then 16. Now clearly straight away we haven't got here an arithmetic sequence because our first difference, if I just write down here first, is not equal. So what I need to do is look for the second difference. So if we have a look here, we've got 4 to 8 is a difference of 4, 8 to 12, difference of 4, 12 to 16, difference of 4. So we've now got a second difference that is equal. Now what that means is that this is going to be a quadratic sequence. As soon as the second difference is equal, we know it's a quadratic sequence. And with quadratic sequences, to find out how many n squareds we actually get, we need to halve the second difference. Half as 4 is 2. So we know that this is going to give us a 2n squared sequence. So now what I'm going to do is move down the page a little bit, and we're going to have a look now at actually writing down this sequence. So what I like to do is start off and write down n and write down the terms in the sequence, going here to 5 terms, and then I write down my sequence again. So my sequence, if you remember, was 2, 6, 14, 26 and 42. And then what we do is we work out our 2n squared, because we've said it's going to be a 2n squared sequence. So we write down what 2n squared actually is. Well, 1 squared is 1 times 2, that's give me 2. 2 2s are 4 times 2, that's 8. 3 3s are 9 times 2, that's 18. 4 4 is 16 times 2 is 32. 5 5 is 25 times 2 gives me 50. And what we're now going to look at is we're going to look at our difference between our 2n squared and our sequence. And what we can see is that for the first one, 2, the sequence number is 2. Second one, 2n squared is 8, but our sequence is 6. So we haven't actually got here a basic sequence that can be worked out fairly easily. So what we need to do now is look at our residual value. And the residual value is what we get when we take away our 2n squared from our sequence. So if we do that, we do 2 take away 2, that gives us 0. 6 take away 8, that gives us minus 2. 14 take away 18, minus 4. And then 26 take away 32 gives us negative 6. And finally, we're left with negative 8 here. Excuse me. Now, what we've now generated is another sequence. So we know straight away that our nth term, we've already said, is 2n squared. But what's left over is going to be what we get from the nth term of this residual sequence here. So if we have a look, we can see this is going down in 2 each time. So our first difference is equal. If our first difference is equal, we know it's a basic nth term sequence here. So what we do now is we say, okay, well this difference is minus 2. So to work out the nth term, we just write minus 2n. Go back to what the sequence would have been at the start. Well, if we're going down in 2 each time, oh, sorry, going up in 2 each time, if we go up from 2 from 0, we're going to get plus 2. So our nth term of the first one becomes 2n squared minus 2n add 2. Always a good idea to check this. So let's put some numbers in here. So let's do when n is 2. So when n is 2, we've got 2 times 2 squared, take away 2 times 2, add 2. And what we're looking for this to be is 6 here. So 2 squared is 4, times 2 is 8. Take away 2 times 2, well, that's 4. So 8 take away 4 is 4. Add 2 gives us our answer of 6. Let's just try one more. So n equals 3. So when n equals 3, we've got 2 times 3 squared. Take away 2 times 3 plus 2. See what that gives us. 3 squared 9 times 2 is 18. Take away 6 is 12. Add 2 gives us 14. And that's exactly what I wanted to see. So we've got our nth term as 2n squared minus 2n plus 2. Okay, let's go back now to our second question here. Same thing. Let's look at our differences first of all. We've got 7. 10 to 29 gives us 19, 29 to 66, 37, and 66 to 127 gives us 61. So again, first difference is not equal. So let's have a look at our second difference. 7 to 19 gives us 12, 19 to 37 gives us 18, and 37 to 61 gives us 24. Our second difference. Okay, well, we can see now that our second difference this time is not equal. So it's not going to be a quadratic sequence. So we need to look for a third difference. 12 to 18 is 6, 18 to 24 is 6. So we've now got that our third difference is equal. If our third difference is equal, it tells us it's going to be a cubic sequence, an n cubed sequence. And the way we work out how many n cubes there are is we divide our difference by 6. 6 divided by 6 gives us 1. So this is just going to be a basic n cubed sequence. Okay, let's go down the page again. So this time, if we write our sequence down again, this time we've got n, and we have 1, 2, 3, 4, 5, just like last time. Our sequence here is going to be 3, 10, 29, 66, and 127. And remember we said we've got an n cubed term here. So we work out n cubed, which is 1. 2 cubed gives us 8. 3 cubed, 27. 4 cubed gives us 64. And 5 cubed gives us 125. Okay, well let's have a look to see what our residual is here. Well, from n cubed to s, we've got a residual of 2. 10 take away 8 is 2. 29 take away 27 is 2. And the last two terms remain as 2 as well. This makes it fairly straightforward because we know here that all we need to do to our n cubed term is add 2 each time. So our nth term this time becomes n cubed, add 2. Fairly simple, that one. Let's just check that these, put some numbers in here. So let's say when n equals 2 again, we have 2 cubed plus 2. 2 cubed is 8 plus 2 gives us 10, which is what we wanted to see here. And when n equals 3, we've got, okay, let's put that in. We've got 3 cubed plus 2. Well, 3 cubed is 27. Add the 2. Gives us 29, which is exactly what we wanted to see. So we've got our nth term of n cubed plus 2. Okay, and back to the last one. Excuse me. Okay, question 3 then. Question 3 here, we've got, let's do our differences first of all. So we have a difference of 13, difference of 29, difference of 51, and a difference of 79. That's our first difference, clearly not equal, so it's not an arithmetic sequence. Let's have a look now at our second difference. Second difference gives us 16 and 22 and then 28. Again, second difference, not equal. Third difference, 6 and 6. So our third difference is equal, which we know from question 2. If we divide 6 by 6, we get 1n cubed. So it's going to be an n cubed sequence again. So again, down the page. Okay, this time let's write our sequence out again. So n is 1, 2, 3, 4, and 5. Our sequence here was 7, 20, 49, and 100, and then 179. And remember, we know it's an n cubed sequence again, so we need our n cubed, which gives us 1, 8, 27, 64, and 125. You'll get used to writing these out all the time now. Now let's have a look at our residual. So residual this time, 7 take over 1, that's 6. Then the second one we've got 12, then 22, and then we've got 36, and finally 54. Well, let's have a look at this. Now this is clearly not an arithmetic sequence, so what we need to do is we need to look at our differences again. And for this one we've got 6, then we've got a difference of 10, difference of 14, and finally a difference of 18. So here we know first difference is not equal, so not an arithmetic sequence, so we've got to look again here. So let's have a look now at the second difference, which is 4. So we now know that we have got an n squared sequence to add to our n cubed sequence. Because our second difference is equal, our n squared is going to be 4 divided by 2, which gives us 2n squared. So we know now that we've got our nth term is going to equal n cubed, but it's also going to equal 2n squared on top of that. Now what we need to do is compare our sequence here with 2n squared, because we're basically working on another sequence here. So if we look at writing down 2n squared now, 2n squared, that's going to give us 2, 8, 18, 32, and 50. And now what we're going to do is we're going to compare our residual sequence with our new 2n squared sequence. So what we get now, 6 take away 2, 4, 12 take away 8, 4, 22 take away 18, 4, 4, and 4. So now we know that we need to add 4 onto all of these to get to our final nth term. So we get n cubed plus 2n squared plus 4. Let's just put some numbers in, just check that. So when n equals 2, putting it into this formula now, we get 2 cubed plus 2 times 2 squared plus 4. 2 cubed is 8, 2 squared is 4 times 2, that's 8, that's 16, plus 4 gives us 20, which is exactly what we wanted. And let's just finally try it with one more number, n equals 3. So we've got here 3 cubed plus 2 times 3 squared plus 4. 3 cubed, 27. 3 squared is 9 times 2, 27. Add 18, that's 45. Plus 4 gives us 49, which is exactly what we wanted for our third term. Nth term then, n cubed plus 2n squared plus 4. Okay, hope that helped. Thank you for watching. Please watch some of my other videos as well, and please subscribe to my channel. Thank you very much.